Hello and welcome back. If you're following along at home, you'll notice that this is part two. We're picking up where we left off here with our tray sketch. And I think this video I'm going to build this out, extrude it, make the actual 3D model of it, just so we can get a look at what it's going to actually look like when it's cut out of a piece of wood. I haven't decided what exactly my toolpath process is going to be yet, or even if I'm going to use Fusion to cut it out, because there is easier ways to do this kind of work. But in an effort to be a completionist, I'm just going to go ahead and build this out and show it here. Our sketch, if we edit it, we can see all the measurements here. And we're just going to build this up from a 2D shape to a 3D shape. So the first thing I want to do is select this outside edge, and that's going to be the walls of it, if you will. We're going to press extrude, and the piece of wood that I'm using is 1 inch, so I'm just going to set this to 1 inch. Press OK. We want to put a base in the bottom of our tray panels here, our little sections. So we're going to turn the sketch back on, select them, all three. You can hold down Shift and click to select all of them. Extrude, and I've found that 1/8 inch works pretty well for general purpose trays, so we'll change their distance here to 125, which is 1/8 of an inch. Join is which operation we want to use, because that will join this extrusion to this extrusion and make it one piece. We press OK. Let's go ahead and hide our sketch. So now we're working with this, and that's a pretty good tray on its own, but as always we can make it a little bit cooler. What I'm going to do is shift click all these top lines here. Sometimes you have to zoom in to select the line just the way you want it. And with all of them selected, I'm going to put a chamfer. I'm going to make this chamfer 1/8 inch. And there's a reason for that, and that reason is because my V-bit tool, my 90 degree or 45 degree, or whichever way you want to look at it, is 1/4 inch. So the radius of that obviously is 1/8 inch. And I'm just going to go ahead and do that for all these interior edges here. Another 1/8 inch, just so they all match. So now that we put our chamfer on, you can see that it's just adding a little flare to these sections. Now this middle one was supposed to be for a pin, and it's 7/8 of an inch deep, and I think that's too deep, so what I'm actually going to do is select the bottom of this section. So let's just select that and hit extrude again and see if we can bring it up another, 1/2 inch minus 1/8 inch is 3/8, so 375. That looks better. Make sure it hasn't grabbed any of the other ones. Doesn't appear to have. Let's try that. Okay, cool. So now our pin won't sit down quite so deep. All right. Another thing that I want to do, and this is going to take some finagling, is chamfer these outside edges. But I'm not 100% sure if it's going to let me do it the way I want to in Fusion. I'm sure it will, but I'm just not familiar enough with exactly how to go about doing it. It likes 0.5. So, do I like this? I guess that's pretty cool. It's not exactly what I had in mind, but now that I'm looking at it, that'd be pretty cool. And then we don't have any real thin edges that we're going to be worried about blowing up. So, oops, all things being equal, this is what our tray is going to end up looking like when we're done with it. So I guess because that only took a few minutes, let's go ahead and talk about how to set up a CAM. This is the CAD, Computer Aided Design. Fusion 360 also does CAM, which is Computer Aided Manufacturing. I'll probably use a different program to actually cut this out because it doesn't require all these complex toolpaths. But for the sake of completion, I'll go ahead and do it here. So that we have our model, we're going to change our workspace to manufacture. And by default, it's in millimeters. But this is America, so we're going to use inches. Before you can add toolpaths to this, you need to do a setup. So here's the setup button. And it's going to ask us a series of questions. The first one, and the one that you want to do before anything else, is where do you want the machine's origin to be? Where do you want to start cutting from? And I always pick the bottom left top corner. So once you've got that, you click the stock tab, and it's going to ask you what size block of material are you cutting this out of. Generally, relative size box is good, but we're going to use fixed size box. Now you'll recall that we made this 12 inches tall by 17 inches wide. So we've got 17 inches in width, 12 inches in depth, and the height is 1 inch, which is exactly what our stock is going to be. So if I zoom in here, I can see where it's going to remove compared to where the model is. We didn't want to take any off the top or the sides, so this should work pretty well. So we've set our origin point, and we've told it what size stock we're starting with. So we're going to press OK. And now we can start talking about toolpaths. For the most part, there is no 3D carving needed on this particular project, so we're going to use a majority of 2D toolpaths for it. We're going to select a 2D pocket, and we're going to say we want to pocket this section, shift click, pocket this section, shift click, pocket this section. It's going to say, okay, what tool are you going to use? Well, we're going to go to our library. I'm going to use a 1/4 inch 3-flute. Spindle speed, I usually change it on the fly, but we're just going to leave it at 10,000 right now. Cutting feed rate, I keep it around 90. Plunge feed rate, we'll make it 60. I can reduce this on the fly if it starts to cut weird when it's actually on the machine. So this is a good place to start. Again, here's the geometry. The heights aren't too important. Passes, maximum step over. So we have a 1/4 inch tool. We really only want to use like a half of that at most. So that would be 1/8 of an inch of step over. And I think that's actually what I'm going to go with. You can kind of fiddle with these, but a 1/2 inch will put less load on the tool. There'll be less deflection, which will give you a better finish. Stock to leave, I'm not going to worry about that. I'm just going to cut it right to the edge. In this last tab, you don't need to worry about too much, at least not on this project. So we've selected a tool. We've set our spindle speed. We've set our cutting feed rate. We've told it what we want it to cut. And we've also told it that our step over is 1/8 of an inch. So you press OK and you let it tell you what this is going to look like after that toolpath. You can see these little blue lines are the toolpath. The red is the tool, and everything else is the travel. See that that's going to cut out exactly how we wanted it to. But I think it's going to go full depth right off the rip, and I really don't want that. So I'm going to right click on our pocket and hit edit. Let's see, passes. We forgot to check multiple depths. Maximum roughing step down. So per pass, this is the maximum that it's going to step down. I'm just going to set it at 100 thousandths or 0.1 inches. Finishing step down is whatever, even step down, doesn't matter. We just don't want it to take the whole depth all at once. We can actually right click and simulate this. We can see it's going to take 2 hours. So I might have to play with the feed and speed of this quite a bit. But this is the path it's going to take. I'm going to turn off the toolpath. So this is 2 hours worth of work. Let's watch it, real time is probably about like this. Maybe a little less actually. I take it back, that's pretty good. I'm just going to let it cut for 2 hours because I feel like I'm going to be happier with the end product. So I'm going to exit the simulation. This inside chamfer. And we want the point of the tool to be on this line. So let's see if it'll let us do it this way. A lot of working in Fusion is trying to figure out how to get the program to do things the way that you, the way that you want to do them. So I've selected that whole outside edge there. I'm going to use a contour geometry. That edge. Okay, it likes that now. So our tool is going to be a little bit different. It is a 90-degree V-cut, but it is not a 1/2 inch in diameter, so I have to add a new tool. Let's try it with a chamfer mill, which it is, but sometimes Fusion doesn't let you do a contour with a chamfer mill for whatever reason. It's kind of stupid when you think about it. The tip's not technically 0, but we'll go ahead and call it 0 just because. Overall length, we'll call it 1.5 inches. Length below holder, 1/2 inch. Flute length is probably 1/4 inch. Yeah, that looks about right. So let's see if it'll let us use this tool to cut the chamfer. It might. 5,000 RPMs, yeah, okay, whatever. I'll change it on the fly. 40, I start at 90 and then adjust from there. We're going to do the same thing we did with the pockets. Well, let's see how this turns out, actually. It looks like it's actually going to cut that chamfer the way that I want, which is surprising. We're going to simulate and verify. 38 seconds, so it's going to plunge 1/4 inch down and then burn out all the way around. Which might leave us with some finish considerations as far as, are we going to have to sand this? Or is it going to be chattery? I think this tool is stout enough that it should be okay. So we're going to try it. That being the case, I'm going to edit this. And here in geometry, I'm going to tell it, you know what, let's do this one and this one too. And that way I only have one tool path for these chamfers. We're going to simulate minute 13. I'll probably slow the feed way down for that. So it should take a little bit longer, but maybe not have quite as many issues. Run the simulation. it's going to behave the way that I think it should behave, which is good. We're going to exit the simulation. So I've got two more toolpaths that I need to make for this. The first one is this big chamfer. Let's do a 3D contour. Select that geometry, that tool. Let's see how it handles this. Invalid tool type for milling. Yeah, okay, so you can't do a 3D contour with a chamfer tool, which is really unfortunate. So let's try something different here. We're going to fake it out and tell it we're not using a chamfer. We're actually using a tapered mill. So I'm telling it now to only touch these 8 faces, I believe. That looks better. Let's run the simulation. 5 minutes. This might work, or I might end up hitting my collet on the edge. We'll try it. And then the final toolpath is to cut the whole thing out. So I'm going to do a 2D contour, and I'm going to select the bottom edge to just tell it, let's just cut this whole edge out here. For the tool, we're going to go back to our 1/4 inch 3 flute end mill. Again, 90 inches per minute, and I can slow that down on the fly as we're cutting it. Multiple depths, maximum step down, 0.1 inch. There's no step over. Let's see how it behaves if we run it like this. That looks like a good toolpath to me. So let's go back to our 3D contour, and we're going to work on our tool a little bit. Okay, so I figured out what I was doing wrong in regards to setting up my chamfer cutter. The flute length was only 1/8 of an inch instead of 1/4 inch, and the shoulder length can come down. See, what I had was 1/4 inch here and 1/4 inch there, which gave me this humongous triangle. But if I change the shoulder and the flute to 1/8 of an inch, this is what my cutter actually looks like. So let's simulate this and see if it behaves the way I hope it will now. It thinks it's going to crash, which it very well might. And it still doesn't go all the way to the edge. So what I'm going to do is drag this down below the cutout. So it's going to cut it out, and then it's going to do that contour. And let's simulate it now. See, I've already removed this excess material, so by the time the point of this cutter gets to this line, that line is still there. This is the part that I was actually worried about having to come up with toolpaths for, because when you get into 3D toolpaths, it gets a lot more complicated. Of course, we had to do this because our cutter is so short and we can't take this all in one pass. Tool outside boundary. Hang on, let's go back to maximum step down 0.4. Let's try this. That's a lot closer to what I wanted, but it's still not quite there. So let's see what it thinks it's going to do. This is correct so far. And here's where it starts rubbing. I actually quite like that, except for I'm going to add another 2D contour. No, let's do a 3D roughing. We'll call it a scallop. And we're going to use a 1/4 inch 3 flute. None of this really matters right now. I'm just trying to see if it'll work. We want it to do a rough machining just these surfaces. Let's see, stock to leave, we'll tell it 20 thousandths. And we'll pull this contour down below it. And we'll see what we get when we run the whole program. 2 hours and 19 minutes. We're going to do the pocket first. Oops, hold up. Cut out. We're going to do a rough machining here. And the contour is going to come back around and clean all that up. That's it. It's beautiful. It's perfect. I love it. Cut, print. That's what we want to do. So that's how we cut this whole shape out. So let's recap real quick. 2D pocket. It's a 1/4 inch flat cutter. Multiple depths selected so it doesn't try to hog out all that material at once. It takes it step by step. Second, we go to a 2D contour, which is our little chamfering tool to do these inside edges. Take a look at that real quick. Here's our geometry tab. We just selected these lines, told it right here which cutter we wanted to use, and it went ahead and it's going to do all that one pass, which is fine. And then we cut out the outside edge with another 2D contour using the 1/4 inch 3 flute tool. Selecting the bottom edge, and again using multiple depths, and then a scallop, which is a 3D toolpath that only touches these surfaces. So we can see right here we set it to avoid and touch, touch. We selected our surfaces, so it's going to rough cut all that out, and then we're going to come in and clean up this giant chamfered edge with our contour path. So the last thing that you're going to do, we're going to select our first tool path, select post. So this is step 1, and this was the pocket, and it was the 1/4 inch flat cutter. We say post, and it's saved. Our 2D contour, we're going to post process. This is step 2, and it is the all chamfer post. 2D contour, post process. This is step 3, the 1/4 inch flat cutter, And this is the contour. Post-process. So step 4, which is also the 1/4 inch flat, and it's a rough outer contour. And then finally, this chamfer that we worked so hard for, step 5, small, large chamfer, finishing pass. And that's it. We're going to save it. And we'll go ahead and simulate it one more time. And the next time we look at this, it's going to be when we're actually cutting it out, doing our tool changes, watching these programs run. A lot of Fusion is messing around with all your settings, your tool settings, your toolpath settings, your geometries, and trying to get it to do what you think you need to do based on what it's telling you it will do. Here's our contour cutout. And our rough for the scallop here. I don't know why it's going around in different directions, but that's okay. And then our final pass with our chamfer tool, just to take it down. And this is probably going to finish up really nice. So that's it for this one. I know it's been kind of harebrained and chaotic. Trying to come up with good toolpaths takes some tinkering. So make sure to leave comments if you have questions. Leave questions if you have questions. Comment if you have comment. Go ahead and click the subscribe button so you'll be in the know when I post the video for actually cutting this thing out. Thanks and have a good day.